everybody, and welcome to our webinar on AI in sports, application of computer vision to improve athlete performance. We really appreciate all of you taking some time out on a Monday evening to join our webinar. So thank you very much. I'm Mani, and I'll be your MC for this event. So as far as today's agenda is concerned, we'll start with the welcome address, and then we'll move on to our keynote speech. After the keynote speech, we'll have a 10-minute Q&A session, and then we'll have a closing remarks from our founder, Duke. Before we start, we have a couple of requests. We would like you to change your screen name to your first name or last name or whatever name you want to be called as. And this will help us to interact with you during the Q&A session. So let's see. I think most of you have your name already, I guess. Yeah, the second request is we would really appreciate if you could wait for Q&A session to ask your questions. Or if you think that you'll forget those questions, then you can just type them in the chat box and Mark will revisit those questions during the Q&A session. Okay, thank you for your cooperation. Now, though Techies is a very famous company, there is a chance that some of you might not know about us. So I'll just give a brief introduction of our company. So this is our founder, Duke, who established Techies 3 years ago. So Duke is a very accomplished software engineer who has more than 13 years of experience in some of Japan's biggest tech companies like SoftBank, Rakuten, and Line. Duke was a former technical advisor at SoftBank Business Development Unit and overlooked many high investment projects, including the one in which he helped SoftBank bring in Alibaba Cloud in Japan as SoftBank Cloud. The mission of Techies is to be trusted partners with both SMEs and multinational and provide them with necessary resources to overcome critical challenges and create long-term value. Though Techies is a fairly new company, we have provided our services to more than 30 plus clients in past 3 years. Some of the notable clients include SoftBank and its subsidiaries and joint ventures. For instance, MeTruck here is a joint venture between SoftBank and Nippon Express, and is a fairly new big player in the market, which provides transportation management system to companies in logistics industry. Then we have Guardant, which is a joint venture between SoftBank and Guardant USA. And this is an oncology company which deals with treating tumors and cancer. Then we have Japan Computer Vision Corporation, which is an AI company. And this is actually a subsidiary of SoftBank. And other than that, we have also worked with clients such as Shonan Seminar and Oyo Japan, etc. Now, Techies offer services in mainly 4 core areas: data science and AI, mobile and web system development, cybersecurity, and cloud computing. Other than the industries I mentioned in the previous slide, we have offered services to companies in industries such as human resources, telecommunications, cryptocurrency, and financial services. Now, as we are here today to talk about AI, I would like to explain some of the solutions that Techies provide to our customers in AI and data science field. So the first is monitoring and detecting anomaly. So Techies team are expert in designing AI and data-driven system which can monitor and predict anomalies beforehand, which helps companies to reduce time wasted on manual configuration and troubleshooting. These include some of the suspicious abnormal human behavior we can see in places such as offices or classroom. I think this is something which everybody here knows about. This is nowadays we have examples such as Amazon or Netflix, where they recommend you movies, TV series, or consumer goods based on your purchasing behavior or streaming pattern. So AI, the team at Techies are expert in creating recommendation system, which helps the customer or our clients to understand their customers and enhance their user experience. Now, this is again a very common thing nowadays. Doesn't matter if you go to any website or you open any app, you can see these conversational tools, aka chatbots, interacting with you and answering your questions. So Techies team can build this conversational tools for the customers, for our clients, which will help them to interact or increase their engagement with their customers, and also gain a lot of data and insights to further improve their services and understand their customers better. There are some of the AI projects that Techies undertook in the past, which I would like to talk about. So the first is the classroom behavioral system that Techies built for our client Shonan Zeminar, which is one of the largest cram schools in Japan. So Shonan Zeminar wanted to have a system which could monitor classroom behavior to optimize teaching. So Techies team built a system capable enough to evaluate and recognize behavioral cues using data, using AI, to provide feedbacks to teachers and the administration. Basically, the system works in a way that it analyzes the classroom as a whole and infers whether the students are being distracted or are being attentive. Now, this is the collaboration project where our researchers collaborated with other researchers to figure out the feasibility of using a single camera to analyze sport performance. So the system actually analyzes the player's pose and body movements and then compares it with other players to check for differences. And then this information is given to the player to work on during the training. And Mark will actually touch upon this subject in detail during his main presentation. So now we'll move on to the next presentation, our main presentation. So before we move on to main presentation, I would like to introduce Mark. So Mark is a data scientist at Techies. He has PhD in physics from Chiba University and has masters in computer engineering and also in nuclear engineering. He is a very good and accomplished data scientist and has worked at FTP Software and now at Techies. So we'd like to move to Mark for our main presentation.
Thank you, Manny, for this very long presentation, introduction, sorry. I'm Mark, and I would be your keynote speaker today. So here are the points I would like to talk about. First, a quick introduction and some historical examples of computer vision applied to sports. Then we will focus a bit more on some specific problems, such as object detection, tracking, motion analysis. We'll see how we can combine those systems to make a sort of AI coach. And we'll touch upon some Techies projects related to that. So first of all, computer vision has been used for quite a bit in sports now, and I'm sure everyone here is probably familiar with its use in the sense of improving the viewer's experience. A very common use is overlay in a sports broadcast, where here you have two examples in soccer and in running, but this is hardly the only use for computer vision. And in particular, it can be used to improve the athlete's performance and give a lot of insight for the coaches. And a lot of problems that occurs in sports and computer vision in sport in particular relate to object identification and tracking, pose estimation, action identification, and many, many more. Now, one of the first problem that occurs in computer vision in sport is to answer the question, where is the ball? Now, a very early example and very common famous example of it is the Okai system that's been used for quite a while now in tennis and cricket and some other sports. And that is used even in the sport itself as a way of helping the referee make decisions on whether a ball is out or in. And not only that, it's commonly used by pro athletes to help them train and by detecting the accuracy of their shots. Now, obviously, this problem of detecting where the ball is hardly restricted, to tennis or cricket. It used to be a very high tension and highly dramatic topic in soccer, where in the past many outcomes of some of the most famous games were decided on whether the referee correctly or incorrectly called a ball for being inside or outside of the goal. Here you have two famous examples in World Cup involving England and Germany. But this is not so much a problem anymore in football, thanks to something called goal line technology. And goal line technology and typically on the way it's been implemented with computer vision uses a bunch of cameras around the pitch, the field, and calculate the 3D coordinates of the ball in real time, helping the referee make the decision. We can see here a typical pipeline of a goal line technology using computer vision. So here, for example, you have a bunch of cameras around the field, 6 cameras, and each camera is associated to a processing node that will have the task of performing a certain amount of operations, such as calibration, ball recognition, ball tracking, etc. And you will have another supervisor node whose task will be to synchronize all of this data, to combine all this data to make 3D estimation of the position of the ball and to make the final decision on whether the ball has crossed the line or not. Now, another topic for object detection is not only to detect the ball, but also to detect the ball and the players. And as for detecting the players, it turns out the state-of-the-art AI model in computer vision are actually pretty good to do that. And it has a lot of advantages to be able to detect automatically the player like that, because it allows to drive statistics and give a lot of insight from plays in any kind of team sport. Typically, you can see an example here in football, in basketball, in rugby. And we'll take a bit more example when it comes to football, but I want you to keep in mind that all of these techniques that we will see are applied largely to any kind of team sport. And when it comes to object detection, in particular player detection, most of the AI solution for that problem rely on convolutional neural network, for example, YOLO and RCNN techniques. Now, when it comes to object detection, there's a few issues that occurs and a few problems that the AI engineer needs to solve. A typical example is objects that are difficult to distinguish from each other depending on the colors or the shapes. A common example, especially with low quality video, is to have the keeper's glove being mistaken for a ball because of their similar color and somewhat similar shape in certain angles. Another extremely common issue is the problem of occlusion. So when another object is in front of the object we are trying to detect. And this is something that happens obviously all the time because we have a different amount of players on the field. And this is also something that a lot of AI models try to address. Another issue that happens quite a bit is the quality of the input, the input. So it can be because of low resolution, of image compression. And there is also something because that is called motion blur. And because of the dynamic nature of the image, it can be a problem. It appears. Motion blur typically appears in ball tracking when you will see the ball becoming more of an ellipse than it is a circle because of this effect. And obviously, other effects such as extreme climatic or lightning conditions can have a huge impact on the model and the detection model. Now, for these problems, there's a few a few AI solutions that have been used. In particular, for occlusion problem, there's been method used with sparse learning models and some sort of interpolations, especially related to tracking. But also one direction that's been quite popular recently is to try to incorporate more context within the model to have the game context included directly into the model. Now, the good thing when we are able to detect the players and the ball is that you are able to track them, meaning that you are able to get their position throughout the whole game. And tracking is a very important tool because you can really build the temporal analysis of the player whereabouts during the whole game that will give you a lot of insight. And has also the advantage that you can use tracking to improve the object detection process itself by predicting where the object for example, the player will be in the next frame. So I want to talk about the application of this tracking. One very common application of tracking the players, for example, is to derive heat maps of their movements during the whole game, which gives you very insightful data regarding the positioning of the player and their tactical role during the game. You can also combine that with different action-related data, which will help us, which help you build some action heat maps of the player and see whether they had the role they were expected to have or not. There is also a very common trend, in particular in football, is to have expected statistics. For example, the expected goal statistics, which becoming more and more popular in football, which basically try to evaluate how likely a shoot is to result in a goal. And therefore, having these statistics for each player on each teams allows you to estimate if they overperformed or underperformed the game. And you can have derive such statistics from the position of the players, especially in relation to the players of the other teams. So as a bit of a summary for that first part here's an example of a typical game analysis pipeline for team sports. Here as an example for football, where you would have a first level of the pipeline where you have ball detection, player detection. You can also add some number recognition of the jersey to do some player identification. Then you would have a second level where you would actually use those detection methods to track the players, track the ball. And on a higher level, you can use all this information to recognize game aspects, game events. You can calculate statistics and more insights for your game, for the coach. But object detection and computer vision in general is hardly only used for team sports. It has a bunch of other applications. And here's another example in what we call foot contact detection that is useful for sprint training. So here in that example, we detect where the sprinter has their foot with contact to the ground, how you can derive how long they've been in contact with the ground, how long their stride was. And this is a very useful tool for both athletes and coaches to compare run by run what was going wrong, what was going right for the players, and also make some comparison between the athletes themselves. Now, I want to talk also about another direction you can go with computer vision to try to improve your performance and drive some analysis of the sport, and a field that is called motion analysis, and in particular, the use of pose estimation in motion analysis. This is something that is used very commonly in all sports that requires some kind of throwing motions in particular, because those actions are usually very important and an action that you want to optimize as best as you can. And an example here is from American football, where elite quarterback make use of motion analysis and pose estimation to improve their pose while throwing the ball and to make sure they have every little detail right. And one of the most famous quarterback, Tom Brady, is also known to have used that kind of tool with his coaches to improve his game in the past few years. Another example of throwing motion is in baseball, where the pitching motion can also be analyzed through pose estimation. And an example of it is the Chicago Cubs team that won the 2016 World Series. And an interesting thing about how they used the motion analysis is they used that also to avoid injuries. They used that to build their injury risk model to estimate the likelihood of their player getting injured during training or during the game. So it adds another interesting dimension in player management. And so we see a few different techniques from different way to use the computer vision to add value to the coaching. And we can combine this technique to kind of create a virtual coach, either as a standalone for the coach or as a complement for coaching, even if you don't have necessarily the means of the pro players. So for example, you can, if you want to improve in penalty kicks, you want to do some specific training or in penalty kicks, you can look at ball tracking to evaluate your accuracy, especially in combination with target detection. You can analyze your style while you're kicking the ball, do some motion analysis through pose estimation. You can also use ball tracking to detect how fast the ball that you just kicked was going, and then generate understand how much power was generated by the kicker. And finally, you can combine all this to derive some player statistics and identify the points you want to improve. And the very interesting point about all of this is these methods are getting more and more generalized and accessible to everyone. And this is a direction we wanted to go with Tokyo Techies. And this is the reason why I want to introduce to you the following projects. So before we dive into the the main project we want to talk about, which is about archery, preliminary, Tokyo Techies was previously involved in a project about analyzing turning serves using computer vision. It's been introduced by Manny a bit earlier, but the idea was to analyze the motion of the player during the serve and using pose estimation to evaluate what was going well, what is going wrong, and most importantly, draw comparison between players. So here you have a summary of the pipeline where, well, several videos were, a bunch of videos were recorded and gotten from the internet. And then the frames of the serves were isolated. Then the use of alpha pose and post flow to detect the pose, to do the pose estimation, which then we can continue to the analysis. And from the statistical analysis of this data, the position of all the joints, you can evaluate difference between players, and for example, difference between pro players and amateur players, and give some insight at what to make a good serve and where to improve. And armed with that experience of a previous project, we wanted to try a different sport too. And we set our eyes to archery for a couple of reasons. Well, the first reason is that pro athletes are already trying to use cutting edge technology to improve their pose. But we saw that the posture in that sport is mostly static, but also contained within a plane. So we thought we could produce a pipeline without expensive pro equipment and with relatively simple equipment, or such as a smartphone. And as a bonus, it's a pretty fun sport. Now, a small reminder of what archery is, what the goal is. Archery is quite a simple sport on the surface. Armed with a bow and an arrow, the goal is to shoot your arrow at a target. And the closer you are from the center of the target, the more points you get. And the further you are, the less points you get. So our goal in this archery project was to build a pose estimation pipeline for archery pose analysis, and to do so with minimal equipment, because we wanted to be able to produce useful insight for anyone that was looking to improve their shooting. And so we wanted to make it so that you could do that with just a standard smartphone camera. So we divided in the project in a few steps: data collection, pose estimation, processing, and finally some analysis. For the data collection, we decided that there was nothing better than actually going to the field and try to test ourselves, because we wanted to experience the actual process. We wanted to identify potential practical difficulties and make sure that our imagined setup made sense and we had control over that. And as a very good bonus, we also had that also allowed us to get some amateur data from people who are complete beginners like me in our data pool. In the future, we also want to make use of the data we have gathered on YouTube from pro archers, because of the large sample available, and because it's also a test for non-controlled conditions. Now I want to talk a little bit about the framework that we use for that project. Our pipeline was based on the MediaPipe framework. MediaPipe is a cross-platform framework by Google, and it's used for building multimodal applied machine learning pipelines. And in particular, what we were most interested in that MediaPipe was the pose estimation module that is based on Blaze pose for a number of reasons. The first is at least according to our test, we saw that they had pretty good performance. Another very important point for us is that it was able to run on smartphone. And as a very good bonus, within the MediaPipe framework, there's a whole ecosystem oriented around sports and fitness, which gives us a lot of options also to improve on. Now here you have a small selection of some results. Here you can see on the left an evaluation of the pose of an archer while doing the shooting motion. And from that, we can derive the position of some particular joints, especially joints that are going to be important for us in analysis, typically elbows, wrists, etc. And one example of what we can do with that information is detecting the shooting position. So here's an example on the left. You see an archer on the shooting position, and You can identify that pretty clearly with the position of some specific joints, such as the elbow. You can see the elbow and the wrist are pulled to the right of the archer, and his left arm is extended. That you can contrast to the more relaxed pose on the right. And another thing you can do is to give some more insight on the actual pose and what you're doing wrong and right. And here you have on the left a very good example of what not to do, a very good a beginner mistakes, where the archer, me, is having a tilted pose. So in archery, in general, you want to have quite a straight pose with your shoulders and your hips aligned, which give you more stability for the shoot. And so you want to try to avoid this kind of tilted position. And you can see on the left, for example, the shoulders and hips are not quite aligned. The hips themselves are tilted and the torso in general is tilted. That you can contrast that with a better pose on the right, where the shoulders and hips are aligned, no tilt in the torso, and this is more the kind of pose that you want to achieve. And now I want to talk about also what is the future for this this project. What we tend to do to put it forward. We want to dive deeper in analysis. We want to be able to do also some performance prediction. So depending on the pose, try to predict the score, do some progress tracking, make use of some auxiliary measurements too, and also train our own model to see if we can improve the accuracy of the current one we're using. I do want to take a little bit of time to talk about what we tried but didn't necessarily work out for us. I mentioned in the beginning that we were attracted to archery because of the very 2D aspect of it, but we still make some experiments with 3D pose, and we did not have a very good result. We realized that the current model that we tried were a bit too unreliable to our taste. But there's been a lot of progress recently in that field. So this is something we are monitoring quite closely. Not something completely related to computer vision, but we did a little bit of some analysis to try to detect the arrow release depending on the sound of the bow that the bow makes. We had some quite difficulty with noisy environment, even though with clear environment, it was quite easy to do. But in general, we also are more computer vision focused team. So that is the direction we've decided to focus on. So I want to summarize a bit all we saw today. Computer vision is being used in a variety of ways to improve the athlete's performance. As we saw, we can do in-game performance evaluation. We can do some specific training using motion analysis, tracking. But you can also do injury risk evaluation, and you can also do some tactics evaluation. So there is a lot of dimension to using computer vision in sports. Thank you for your attention so far. Now we are going to move to the Q&A session of the presentation. So please use the raise hand function on Zoom to ask your question, or otherwise type your question in the chat box. We will take a look at the question previously asked. And for that part, I will be joined by Yoshi, my colleague and computer vision expert, to help us answer your question. So please go ahead. Okay, so I have already a few questions. A question from Han. Does a master degree in nuclear engineering help with AI research? No, not really. Thank you for your question. But it does, in general, help to have a scientific mindset, especially when it comes to research application. You want to be, how to say, comfortable diving into the papers. And how is the performance in the archery AI models? Is it comparable to modern AI models in other sports? It's a difficult question because it's difficult to compare sports in the first place. I'm sure Yoshi can add a bit more on my answer on that. But we feel because of the nature of archery, because of the like we said, the pose is relatively static, that there's much more. It's more easier. It's easier to do so than to evaluate it rather than sports that are more dynamic. In general, pose estimation works a bit better when you have less dynamic events. I don't know, Yoshi, do you want to add a bit on that?
Okay, thank you, Mark, for your part. I am Yoshi. I am the main engineer in charge of the archery analysis and also the tennis project mentioned before. As I have experience working in both tennis and archery, I can tell that first of all, like Mark has already said, it is not really easy to directly compare the performance of one model to the other in different sport. And yeah, it don't really make sense comparing sport, different sport together. However, in my experience using pose detection model with tennis, which is a more dynamic sport, and archery is a more static sport, I can say that in tennis, it is likely to encounter mistakes. And for example, camera angles can be a very big part of the accuracy. In archery, we are lucky because the player, the archer, stands still, and we can fix the camera and don't have any problem with camera angle. So, well, in a sense, doing archery analysis is kind of easier than in tennis. So, well, we can say that the accuracy in archery analysis is a little bit better, not due to the model, but due to the nature of the sport. I hope that answers your question.
Sorry, I just want to follow up if you don't mind. So the performance that I was talking about is the evaluation, right? So for example, if your model predict like how many points you're gonna get when you do certain pose, and is that correct? Like 50% of the time, like 30% of the time, that kind of thing, that the evaluation, right? So the performance in terms of accuracy is that comparable to like what we have in other sport, that kind of thing? The accuracy is what I mean by performance.
So you relate the accuracy to the ultimate score, right?
Yeah.
Yeah. This is actually difficult to compare again. An example in archery is quite possible to have a very bad posture and by some luck, for example, hitting the center of the target. So at the end of the day, you will have to not only look post by post, but more a statistical analysis of this pose over time and over many repetitions. So depending on the type of framework you use for accuracy, what you intend to do with the accuracy, it can be quite difficult to compare. And I don't necessarily see any natural, straightforward way to do that from sport to sport.
And well, and truthfully, we mentioned in the slide, but the performance prediction for our archery project is actually something we plan to do in the future. So we don't have any data to back up whatever we say at the moment about accuracy. Sorry about that.
Okay, no problem. Just curious. Thank you.
Thank you for your question. We have another question for Paul Jones. Have you gone beyond just testing or have any plans for POC or like? Well, it is definitely in the plans. I mean, we are actively working on it. And I mean, our current version is quite rough. So there's definitely a lot of work to do there yet. But no, this is something that we want to have something more polished in a very, very, very short term. Does that answer your question?
Yeah, please. Paul just raise his hand.
Hi guys, can you hear me?
Yes, we can hear you. Thank you.
Great. Thanks for your presentation. It was very informative. Guys, I represent SoftBank and we actually have a computer vision platform, probably one of the best in the world. And we've actually just opened it up to developers. So I'm curious to be on this today to listen to how you're progressing and what kind of SDK platforms, etc. you're working on. So what I'm trying to work out is how far along you are in terms of, you know, developing this into sport. Have you actually taken it into mainstream sports such as in Japan, like baseball or soccer or etc.? So be very interested to sort of see if you have, and if you haven't, I think I can definitely help you out.
Yeah, we would love to have more contact with you. So far, we've been focusing on the archery side of it for conveniency, and because also we wanted to have something more polished for moving on to something else. But yeah, we'd absolutely love to hear more about that from you.
Yeah.
Great. Thanks, guys. Really enjoy your presentation. Not an easy thing to present, so well done.
Thanks a lot. Do we have any more questions? Oh, we have one more question from Khan. Two more questions, actually, come as a bundle. I am curious about AI in goal line technology. Why do they use RCNN YOLO? As far as I know, they are not the best ones in terms of accuracy. Well, goal line technology, there's quite a few, there's a few different actors that don't necessarily use all the same technology, and they don't necessarily disclose what they are using. I mentioned that those RCNN YOLO are common examples in the field for such kind of techniques. But in any case, I think Yoshi can maybe develop more on that, but in terms of, you're not only looking at the accuracy of a model to put it into mainstream, into the industry, there's a lot of other factors that come into play. And so sometimes having a robust model is just more important than having an accurate model. And especially you need to realize that there are other considerations coming into play, such as how heavy your model is, how much better really accuracy it is compared to other models. Yoshi, do you want to allow?
Thank you, Mark. So I'm trying to add a little bit on that. So as if you work in computer vision, you will know that this is a very rapid advancing field, like new model, better model coming out like every month, and sometimes in like a few a month. Accuracy is the most important factor to be considered in the academic setting. So academic researchers compete with each other to improve the accuracy of their models. Sometimes just a 0.1% increase in the accuracy may become something very like people can get very proud of their like small increase in accuracy, but sometimes it comes with a trade-off in speed. In my experience, the state-of-the-art models, the most the latest coming out usually have the best accuracy, and in this case, yes, RCNN and YOLO is not the newest one, and certainly will not have the best accuracy. However, what they offer is speed and lightweight. So especially in case of YOLO, and with the newest version, YOLO version 4, it literally is 100 times faster than the best model, the highest accuracy model. So it is more practical to use both to use more robust and accurate model instead of just focus on accuracy. I hope that answered your first question.
Yes. Okay. Thank you, Kan. You have another question from Kan. The pose analysis seems very nice. Many people do yoga exercise at home nowadays. They may be interested in the pose analysis to improve their practice's quality. How do you think about that? Well, actually, the MediaPipe framework itself was developed in part and to respond to that demand. It has been from the beginning developed with fitness and yoga in mind, so that you can see a lot of application and people using that type of framework for such kind of application. And this is something that is booming. I'm sure if you take a look at new apps on the store right now, you will see a lot of yoga exercise apps that will try to bank on that.
Yeah, one use case I can think of about yoga maybe to accurately practice what you are meant to practice. For example, some people I know practice yoga every day, but it seems quite difficult for some some action or some pose to be performed well. For example, you are supposed to raise your leg up to your hip or higher, but yeah, sometimes people just don't see that and just see the motion of raising the leg. So imagine having some computer or just your smartphone telling you, hey, you are supposed to raise your leg a little bit further. That could immediately provide feedback so people can improve and have a better practice session. This is just something on top of my head.
Yes. So if that, let us know if that answers your question, Kan. And I think, is that if there's any other question, well, we can still take them, I think. If there's no further question, then we'll be closing the seminar and moving on to the address. And I will go back to Mani for the rest of the part. Thank you very much for your questions.
Thank you.
Thank you, Mark and Yoshi. Now I would request our founder, Duke, to give some closing remarks. So, Duke.
Hello, everyone. Thank you so much again for joining us today. You know that nowadays, to stay competitive in this fast evolving market, all companies in any size and industries need to put in a lot more effort, right, to achieve the digital transformation. And in that process, Techies' main contribution is to provide the technical solutions to turn their business ideas into the actual working products or services. And that is not an easy process, right? We have to constantly study to acquire practical skills. And it's not an easy process, and we have to do a lot of research like this. And as a young team of engineers working in Japan, we're so passionate about study, and we would love to share our passion, our opinion, and also our learning results to the community so we can all grow together. I hope that you find our webinar useful, and we look forward to seeing you in the next month. Thank you.
Thank you, Duke, for the closing address. Now we'll share the link for the feedback form in the chat box. So you can go ahead and take a couple of minutes to fill out those forms. Yeah. You also have a QR code, which you can see on your screen right now. So this is the QR code for the feedback form. So you can scan this QR code and fill up the feedback form. And there's also a link given in the chat box, so you can check that out as well. So it will take just a couple of minutes to fill the form. So we'd appreciate if you can do that. And now you also have a lot of webinars lined up in next month. So hope we'll see you again. Thank you so much.